Konnichiwa, students. Today we're going to talk about roots. And to get started, we'll talk about a square root. That is just what number times itself will give you the number inside of the root. And we don't write it, okay? We have our root symbol. We don't write a number here, but really there can be a 2 there. All right, number times itself, so just 2 numbers. And then a cube root. This is asking us what number times itself 3 times will equal the number under the root. And that's what we're going to focus on. Now, the 2 shapes that we can think about also are squares and cubes. And if you take a look over here, we have the area of a square is given to us by just multiplying one side length 2 times. Okay? And same thing over here. The side length times itself, or squared, equals 25. So the idea of this root, if we think of this as the area, when we take a square root, that will give us the side length of the square. That's one way of thinking about it. So the square root of 49 would just be 7. If the area is 81 square centimeters, then each side would be 9 centimeters. That's another way of thinking about this. All right, let's take a look down here at our first example. And in this case, we have a cube root, or third root. So we want to know what number times itself 3 times will give us 8. And I've kind of just laid this out for you. And remember, going back to this diagram here, right? If we have a cube, that means all of these side lengths are equal. And what we need to figure out is what number times itself 3 times. Of course, it is 2. All right? 2 times 2 is 4. 4 times 2 is 8. That matches the number under our root symbol. And this number here, 2, will tell us the side lengths. Okay? 2 equals A, 2 equals A, 2 equals A. So that's one way of thinking about this. Now, same idea. What number times itself 3 times will give us 64, and of course that would be 4 times 4 is 16, and 16 times 4 is 64. So remember, the root is asking you, what is this number? What is this number? A common mistake people will make is that they will say the answer is 4 times 4 times 4. No, it's not. The answer is telling you what is that root? What is the number that you're going to use? All right, moving on. This is where things get a slightly more complicated. What happens if you have a cube root or third root of a negative number? Is this even possible? Well, let's take a look. Remember, what number times itself 3 times? And if you do this math, okay, if you have a negative number in the root, well, the root will be negative. Hopefully that makes sense, but let's go through it. If we have negative 2 times negative 2, we get positive 4. Positive 4 times negative 2 is negative 8. So we have accomplished our goal, right? Now, remember, the root is going to be what is that number, so the answer will be negative 2. So once again, summary. If you have a negative third root, if you have a cube root with a negative number inside the root, your answer will also be a negative number. Okay, let's take a look at roots that have fractions. So here we're looking at a square root. We're thinking of what number times itself. And this one on the surface looks difficult, but I'm going to show you a very, very simple way of thinking about this. All right, and the good thing is that even though we have the square root of 1/4, we can break it into 2 separate roots. Square root of 1 and square root of 4. Square root of 1, 1 times 1 is 1, 2 times 2 is 4, and that's it. So what are you going to do? Anytime you have a fraction within a square root, break it into 2 parts. That will really make life easy, or easier. Now if we look at this, we have a cube root of a fraction, 27 over 8. Remember, we can break it into 2 separate parts. What number times itself 3 times gives us 27? 3. What number times itself 3 times gives us 8? 2. And there we go. There's our answer. 3 over 2, or 3/2. And last problem. When we get into this, we have a negative out front of the root. Anytime we have a negative out front of the root, that negative will just carry through the problem. We're going to go back to what we did up here. If we have a square root, we can just break it into two parts. The numerator is a square root and the denominator is a square root. So let's do that. So square root of 36 is 6. Square root of 49 is 7. That negative just follows it all the way through. All right, and the last problem. Now we're going to go back to our shape. We're going to go back to the square. And in this case, we don't know what the side lengths are. We're just going to call them S, as we don't know what they are. We gave them a variable. But we do know our area is 64 square meters. So if we know this, okay, basically we're squaring the side length and we're taking our unit as meters and we're making it square because we have this shape, square. So how do we find the side lengths of the square? Well, you probably won't be surprised, but to find one side length, we are going to take the square root. That's exactly the purpose of the square root. So we start with 64 square meters. We can break this into two parts. We can have our number, okay, which will be our side length, and square root of 64, of course, is 8. And if we want to know the unit, well, square meters, the square root of m squared. Remember, you're thinking about what times itself will give you m squared. Okay, well, in this case, meters times meters. And there we go. Our side length will be 8 meters. How do we find this? How do we find the side length of each square? Well, using a root. All right, there you go.